Hello class. In this video we're going to look at some math methods which will allow us to do some more complex calculations other than the typical addition and subtraction and multiplication and division. And then we'll also look into importing some random number functionality. As we'll see in a minute, the math methods are built into Java and no import is necessary and we can simply just use them. Whereas the random number functions are a special import similar to what we have done with the scanner. We have to import that library into our program. So starting out with the math methods, we'll take a look here in our book and we'll kind of follow along for a little bit. And just some basics here. So the standard math class in Java, it's a built-in set of routines called methods. It's reusable code that we can use in our programs, and it does specific functions. As we'll see in a second, there are a few functions that we're going to focus on: square root, power, and absolute value. There are many other functions that we'll look at as we get through the class, but we're going to start with these, and they can all be accessed the same way in your program. So a little terminology: a method is a predefined function, a predefined set of code that we can use in our program. We do not have to write it. And in this case, we don't have to import it because it's included with Java. So the method call is the way we invoke that method and call that special code. And it will take arguments, so values that we can put in. So for example, if we want to take the absolute value of a number, that number would be the argument that we need to pass in. Similar for square root and power, but power takes two arguments because you need to use the base number and then the exponent. So let's take a look at some examples of math methods. So here are three of them. The square root takes the square root of a number. The power method will take any number and raise it to a power. And then the absolute value of a number, the ABS method, gives us the absolute value, the positive value of whatever number we put in there. There are a lot of great resources on the web that you can use to look up other math methods. I'll post the links to one of them in the resources section, and it's called W3 Schools, and I'll post a full link there. But you can see here's a list of all the math methods that are available to us, and we could scroll down and you could see, in addition, here's the absolute value that we just talked about. You have some trigonomic functions. You have some exponent functions, you have a floor function, you have a rounding function, logarithmic functions, min and max functions, many different math functions that we can use. You don't need to write the code for it. You don't even necessarily have to know how it works. You just need to know what inputs you are going to put into it. It will do the required calculations and give us back a result. So heading back over to our book, we could see the three functions. You've got some participation activities here to try, but we're going to jump over into our lab program in section 35, and I'm going to actually duplicate this and get to a new window so we don't have to keep bouncing back and forth. And we'll go into our lab and we will implement those three functions and maybe one or two more from the math reference, and we'll see the results. So jumping down to section 35, our test area, bring up the IDE, wait for it to load, and then we'll start with the three methods that we want to use. Again, we're going to start with these three, and you see they all take floating point values. You can also use integer values in there as well. Okay, so let us start with a quick test. We'll create a double value, test variable equals, and we'll keep it simple. We'll put in a number of 5.0. And then let's just try each of the different methods. We'll try square root first. We'll just do a simple print. And we are going to do math dot square root of test variable. I'm going to put some text in here too to make it a little more descriptive. And we'll put in the test variable value, some more text. There, nice little statement. It'll have a nice value. And actually, let's change it from 5.0 to 2.0. Be a little bit easier to manage some of these calculations. Let's run it, see if I made any typos. And I did not, which is nice. So here we go. The square root of 2.0 is 1.414, etc., which is correct. We could try a different value if we want to see it. Square root of 4 should be 2.0. Now you'll notice it only gives you one of the roots. A square root has two roots, a positive and a negative. In this case, it's only returning the positive value. We'll put it back to 2.0, test it again. Great. All right, let's move on to the next one, power. Okay, so let's just copy and paste this line of code, and we'll make it the power method. And let's change our text as we write it. And we'll do 2.0 raised to the power of, call it 3, is, and this is where we would change our function to be pow, very assertive function, pow, and we'll give it test variable, comma 3. 2 raised to the power of 3 is, and we would expect the answer to be 8. There it is, 8.0, it's a float. Excellent. And the last one we'll try absolute value this time. And again, we'll copy and paste our line of code. We'll paste it in. We'll change, instead of the square root of, we'll change it to the absolute value of test variable is math.abs. Now, we shouldn't see much of a difference from the absolute value because the absolute value of a positive number is the number itself. So let's change 2.0 to minus 2.0. And before we do that, let's think about the other two functions that we have written. We're going to try to do a square root of a negative number, which is not a real number. It's an imaginary number because it's a negative. So let's see what that gives us when we run it. NaN, I'll come back to that in a second. But if we look at the power, minus 2 raised to the power of 3 is minus 8. So minus 2 times minus 2 is positive 4. Positive 4 times minus 2 is minus 8. And then the absolute value of minus 2 is 2. Now, back to the square root. Square root of minus 2.0 is NaN. So NaN stands for not a number. So it was able to do a calculation, and it realized that what it was going to give us back is not a number that we can use in our data type. So instead of the program crashing, it returned NaN. So if you see NaN in any of your output, you'll know that either your calculations have gone awry, or you're trying to do something that is not a number with a number field. So better to have an NaN value than to have the program crash. Now, if we jump back over to the documentation of the reference and we look at square root, we can click on all these. They're all clickable links. And if we click into it, it will give us a little more information about the method itself. And it has some examples, and you could try it yourself if you want to try them out. And it gives you the definition. It tells you the parameter values. We need a number, and it's required, so we could do the square root. And then it tells you if the return values of this method. A double representing the square root of a number, or if the number is less than 0, it returns NaN for not a number. So you can check to see what the different parameters are and what the methods return in the definitions. So let's jump back over to our lab, and let's see if there are any other interesting functions that we can test with. Let's try. There's a few of them that are kind of neat. For, round, and seal. So let's put those in, but let's change this to a different number. I want to use 2.4. Actually 2.5. And we're going to try out the floor function, the ceiling function, and the rounding function. So I'm going to paste in a new line of code. The floor of, I'll explain what floor is in a second. So the floor function takes whatever parameter you give it and returns the next integer below it without rounding. So basically it strips off the decimal point. So the floor of 2.5 should be 2.0. Let's run it and see. And there it is. The opposite function of that would be the ceiling. I probably should have just copied and pasted, but I'm already too far in, so I'll just keep going. Good thing about programming is you learn to become a good typer over time. Okay, so the ceiling function. Ceiling of 2.5 should give us 3.0, and there it does. These are different than the rounding function. The rounding function will round up or down as we expect, but the ceiling function and the floor function do the opposite. One takes the value above, one takes the value below. Okay, very good. So that is the math methods. Next, let's take a look at the random number functions. Now, one thing to note is that there are several ways you can get a random number. There is a math method called random that will give us a random number. And let's put it in. Oh, I'm not going to fall into that trap again. I'm going to copy and paste. And we'll give it random value. And we'll do math.random. And you'll note that random does not take any parameters. So when I look over here, random takes no parameters, and it returns a random number between 0 and 1. It's a double value. So if I run this, there's my random value, 0.172. If I run it again, there's 0.208. And again, 0.222, one last time, 0.321. Coincidentally, all four of those are increasing. Let's see, up there's one that goes the other way. Okay, so it is a random number. It could be anything between 0 and 1, and that is an easy way to create a random number. And if you need to do something in your code that requires randomness, that might be one way of doing it. We're going to take a look at another way with the random library. Okay, so let's jump back over into our book, and we will go to section 2.18, the next section for random numbers. And you'll see that the random numbers has a library that we can import, similar to how we have imported the scanner. And we're going to implement this, and you'll see, similar to the scanner, we have to create a random number object. And that random number object will allow us to generate as many different random numbers as we'd like, and as many different random number types as we want, as we'll see in a second. So let's jump back over to our code, and we will update the import. And the import is Java util random. For a random number generator. So we're going to create the object, and then we're going to do some prints with a next int. And you'll see the next int, every time we run it, will give us a next integer with the type int. So it can be any value between plus or minus 2 to the 31. It's a fairly large number, so you may not want to be able to use numbers that big, but this gives you the ability to do so if you need big numbers for, well, whatever reason. So let's copy some code. Copy this code out. This way I don't have to type it, and we'll put it into the bottom after our prints for the math, and we'll kind of make it look nice and clean and you can read. There it is. So when I run this, And I'm going to temporarily comment out all our math testing. And we're just going to run it with the random number, and we'll run it. And it gave us a big negative random number. We run it again, big positive random number, another positive random number. Every time we run it, we get a different value. And we could put a few different lines of code in, and you'll see that every time we run this random next int method from the randgen method, we get a different random number. And in this case, we're always asking for integers. So you could see here are our big giant random numbers. Okay, jumping back over into our book, we go through the steps of how we do the import statements. We create the randgen, similar to how we created the scanner. Instead of using scanner, we use random, we give it a name, and we create the new random object. So again, this is an object again that we're using. And the method is nextInt, which gives us the next integer. There are other methods that we can use other than integers. We can specify a double. So let's take a look at that. We could put double in here. Do a couple of doubles. And you can see you get not only a integer value, you get a double value. And again, the double values are between 0 and 1. But the integer values could be anything. Well, let's say you don't want an integer value that's so large, and maybe you want it to be a smaller value. Well, you can give it a parameter. So let's try on this last next int, instead of just letting it pick one at random, let's put a 10 in. This should give us a much smaller random number, 7, for example. Run it again, we have another 7. By coincidence, let's try it again. 5, okay, there's our 5. So now we're getting values between 1, or 0, I'm sorry, and the number we put in. So we have a little more control now. So now we can get an integer in a range of what we're looking for. And finally, there's a third option. We can put in two numbers, a starting and an ending range. So let's put in this next int, the top one, let's put in minus 10, comma 10. So this will generate a random number between minus 10 and plus 10. So you have a lot more control with these random number generators using the random library than you do with the math version. But it depends on what your code is and what problem you're trying to solve. One may be easier to use and make more sense versus the other. Okay, let's clean this up a little bit. Let's comment out these print statements for a moment. And we're going to look at one last feature of the random number generator. So we have the ability to start out the random number generator at a specific value, meaning we're giving it a seeding value, a place where it could start doing its calculations. And we can do that by adding a parameter inside this random when we go to create the object on here on line 19. We can put in a 10. And if I then, well, I'm going to need my print statement after all. So let's put in just a generic system out that print line next int random.nextInt randgen.nextInt. And if I run this, oops, typo. Typos happen a lot. That's okay. We can fix those. And there's our random value with a seed starting at 10. And you can see every time I run it, I get that same value. If I change my seed value to 12, I get a different value. but I get the same value every time I call it. If I had called it a second time, I get a different random number. But every time I run it with a seed value, I get the same starting point. If I remove it and keep running it, I get a different seed value. So now you have control over the starting point of your randomness, which is kind of ironic that you shouldn't be able to do that, but you can. So you can have a different starting point, and every time you start from that point, the same random value happens because the calculations and how it performs the random number are the same each time. We don't know how it does it, but when you give it a seed value, it follows the same logic each time. When you don't give it a seed value, you get true random numbers. Okay then, so that's about it for math and random numbers. Feel free to explore the Java reference for randomness in math and try it out. See what happens, see what you can make it do. And as always, if you have any questions, feel free to reach out. And I will talk to you all next time.